All right, we're back with structure free in the hizzy. All right, so we're gonna do this frame, shear, and moment diagram problem, and it's got this is the frame shown. Oh, I gotta give you a dimension here, and this would be, bam, we'll say obviously not drawn to any sort of scale, but still 40 feet. Okay. And let's see. So we're going to draw the shear moment diagram. So first thing you want to do is calculate reactions. Calculate reactions. And I'm going to do this in a little bit different than some of my other videos, and just visualize this as unfolding as opposed to labeling I's and J's. Okay. But I really, it's kind of like when I go to solve this for the shear and moment diagrams, I'm gonna kind of start from this corner over here and just go in a circle like that. Okay, and I'm just gonna move around the frame this way. uh, this is not a moment, so don't be confused. And two, what we're gonna do, the next thing I recommend doing is blowing up the structure. And when I say blowing it up, I mean cutting it up with here and blowing it up and then isolating all the joints as well. Blowing it up and drawing. Okay. Drawing a detailed with drawing detail with member end forces, if you will. Member uh, end end forces and moments. Slash moments right here. And then third will be drawing the drawing the diagrams. Draw V and M diagrams. And already 2 minutes, and that's too much information already, but let's get on with it. I'm not going to calculate the reactions in this example video. I imagine all of you know how to do it. You have here, this is statically determinate. I have a reaction here at, if I call that A, B, C, and D. I have here AX, oh, AX, AY, and then DY. And if I do my calculations, what I find is that these reactions are, I will have a horizontal reaction this way from some of the forces in the X of 45 kips. Based on some of the moments about a joint and some of the forces in the Y, this will be 25 kips right here, and then some of the forces in the Y or some of the moments about a point, and this will give me 55 kips. So the first thing we had to do was calculate reactions with global equilibrium equations. All right. There, bam. Okay, so now what we want to do is blow up this structure, okay? And I'm going to start again starting from A, going all the way around B, C, D, okay? So here at A, so give yourself enough space on paper. I start over here. Here's member 1, or AB. And so at end A, over here of this location, I had 25 kips going this way and 45 kips going this way. Okay? Between the joints, not the joint load, but between the joints, not this joint load here, but between the joints, I have a 20 kip concentrated load here, 20 kips. And then I have over here, I got to calculate these reactions over here. So if I do some of the forces in, if I'm looking at this, if I look at some of the forces in the horizontal direction right here, I find that I've got, let's see, 20 minus 45, I would get 25 kips this way. To maintain equilibrium in the vertical direction up and down, I need 25 kips this way. And then to calculate the moment over here, I don't know what direction that moment is. Here, I'll just assume it's that way right here. I would say some of the moments, let me do this down here, make sure I have enough space. Some of the moments about the cut right there, some of the moments is equal to 0. So I'm going to calculate that real fast. Let's see, I'll have M minus or plus 20 kips times, I believe this distance was 10 feet, and this was also 10 feet. So 20 kips times 10 feet minus 45 kips times 20 feet equals 0, and that tells me M is equal to, 700 kip feet right here. And so that means that this number right here, this moment here, and I got a positive result indicating that this direction is correct. So my moment here is 700 kip feet. Bam. Okay. Now I want to take a closer look at the joint. So I'm going to blow up the joint over here. So I'm going to go to the joint, and here's the joint at A. I have here's like the member that was cut and another member that was cut. So I cut out or isolate the joint. At the joint, I have a horizontal joint load of 10 kips going like this. Okay. I have equal and opposite from this side. From here to over here, I need to have equal and opposite. Okay, that's not a force. I just have to have equal opposite from this side to this side. I need equal and opposite. So that means 25 kips going to the right. That would say 25 kips going this way. Then I have 25 kips going down or downwards, and so this would be 25 kips going upwards. And then my moment would be equal and opposite, so I would have this would be 700 kip feet. Yeah? All right. Now I got to maintain equilibrium of this joint. This joint has no distances. Okay. So I can't have this thing rotating in space. So let's see here. This thing right here, this has to be, I have to assume that these cuts are infinitesimally small so that there's no arms. So this is also going to be 700 kip feet to maintain equilibrium. If I do some of in the vertical direction, some of the forces in the vertical, I need 25 kips going down this way to maintain equilibrium. And then if I look at some of the forces in the horizontal in this case, this will be 25 minus 10. That means I need to have 15 kips going this way to have joint equilibrium. Okay. And then now I can move on to the second member. That second member is over here like that. And I'm going to have equal and opposite now again. So I'll have here 25 kips upwards, 15 kips this way, and 700 kip feet this way. 700 kip feet like that. All right. And then on this member here, which is 40 feet long, I have a uniformly distributed load that goes all the way here of 2 kip per foot. This is 2 kip per foot. Okay. And I want to calculate my reactions, if you will, over here. Right. So I have a vertical reaction here. This is going to be 25 minus 2 times 40 right here. So this reaction right here, let me give some labels to this for now. So initial labels that I'm going to replace. So V, N, and M at this location right here. So if I do sum of the forces in the vertical equal to 0, I would get V plus 25 kips minus 2 kip per foot times 40 feet equals 0, and that would tell me V is equal to 55 kips. So this V right here, I'm going to turn it red because I know a number now. This V is no longer V, but it's just a force that's pointing up at 55 kips. Okay. And then same thing here with the normal force, some of the forces in the horizontal. This tells me that this is 15 kips to the right, a force of 15 kips to the right. And then I look at moments, and the moments it's going to be a little bit more involved. The resultant of this distributed load is 2 times 40. That's 80 kips here at a distance of 20 feet from this end. So if I sum moments about this point right here, or right here, so I call that O this time again. O equals 0. Here, bam, like this, I would have M plus 80 kips times 20 feet, which is 20 feet, which is this distance to O, 20 feet right here, minus 25 kips times 40 feet, minus 700 kip feet equals 0. Oh, the suspense and the drama. Oh, man. And M is equal to some number that should be 700 minus 1600 plus 1000. is equal to 100 kip feet. And it's positive, meaning that the direction that we said is okay. So I can turn this red now. Red, code red. Suck a drink in Mountain Dew. Oh, I bet many of you watching this video like code red. I do too. I'm not plugging anything. Okay. I wish I had sponsorship, but I don't, right? Damn. All right. All right. So 100 kip feet, right? Video sponsored by Mountain Dew. What's up? Anyway, no, it's not. Right? Shoot. That'll be a first. That might change all of education, huh? Anyway, all right, all right. So here, 100 kip feet. Bam, going on. Now we can go to that joint. You know the story now. So here, I go to this joint here. Uh, let's not put any mystery to it. I solved this pretty quickly. I think. So here's this other joint right there. Bam, I've got a joint load of 5 kips here. So, one thing people always forget to do is put that joint load in there. But equal and opposite. So I've got the 15 kips going this way, the 55 kips going this way, and the 100 kip feet going that way right here. And then reactions, 100 kip feet. Okay, bam. And then vertical, this right here, 55 kips. And then the what is it? The shear on this face, if you will be 15 minus 5. It'll be 10 going this way, 10 kips. All right, hopefully that wasn't too sloppy. That looks kind of sloppy. Let me do that one more time. Let me correct that here. This would be 10 kips going this way, the 55 going upwards, and then the moment right here, 100 kip feet right there. Bam. And then now the last member over here, right here again, equal and opposite, right? And so 100 kip feet, 55 kips this way, and 10 kips this way. And that means over here on this end, right over here, uh-oh, I spelled trouble. No trouble, no trouble. Dang, I almost forgot the loading. The loading is 10 kips on the load here, right here. And then I know from the other side, I've got reaction, one reaction of 55 kips. And if I did everything right, this last member should be in equilibrium as well. Okay, so if I look at forces in the horizontal, I've got 10 minus 10 equals 0. Good. In the y, 55 minus 55 is 0. And then I could do a moment equilibrium about a point, and I should get 100 kip feet. And in fact, if I took moment equilibrium about this point, 10 times this distance right here, which is 10 feet, will be 100 kip feet. Booyah, right? Ka-chang, ka-chang, chang. All right. Now let's move on to drawing these diagrams. So usually what people like to do is have these diagrams right here, these blown up things, and then have some more space up here to draw their diagrams on top. Okay, but we don't have enough space, so I'm just gonna go member by member here. So and I think once you see 2 of them, you'll be all right with the rest. So here, if I start, so let's say I'm kind of like turning my board, my tablet, but here, this would be that first member. We'll call this, let me label these members for us. That way there's no confusion. There's member 1, member 2, member 3. Okay, right here. And so what I would have at member 1, this is member 1, I have the horizontal right here. I have all the end moments and things, or end loading. So I have here the 45 right here. Oh, I gotta read 25 kips this way, and then the 25, and the this was, what was this, 25, 25, 700, 25, 700. Okay, and I can draw my 3 diagrams. So I'll draw my diagrams up on top. Oh shoot, am I gonna have enough space? Damn, let me just do it on the bottom. Okay, sorry. Boom, boom. And I'm missing something. I'm missing the concentrated load of 10 kips, was it? 20 kips to the right. So bam, 20 kips this way to the right. And so here, the first diagram over here would be my axial force diagram. There's my N. Does that look like an N? It looks kind of like an N. I gotta turn my. Oh, west side. Oh, shoot. I don't know. All right. Shoot. Okay, I have some technical difficulties. I'll come back.